Objective 9.2, to be able to find the reference angle in degrees given an angle measure in radians degrees with our calculator, also using it on a graphical plane. What is the exact value of the cosine of theta if negative 3,5 is a point on the terminal side of the angle in standard position? In order to do this problem, first of all, we have to plot our point on the terminal side of the angle, negative 3,5. So we're going to put a scale on our graph, and counting by 1 would accomplish that, and we can plot our point of negative 3,5. Now remember, when we're talking about the terminal side of the angle is always coming from the origin to that point. So we're going to draw that terminal side. We can envision a triangle being made from that terminal side by dropping the vertical and the horizontal to form it. So here is our angle for theta. Now we want to use the information to help us find the exact value for the cosine of theta. Well, by looking at our triangle, we know two side lengths of it. We know that this is 3 units going to the left, and this is 5 units going up. So we could fill in those lengths on our triangle. Now, the cosine's definition is the adjacent divided by the hypotenuse. Well, I do not know the length of the hypotenuse for my triangle, but based on what we have here, we could calculate it. Remember, when you know two sides of a right triangle, you can always find the third using the Pythagorean theorem. The Pythagorean theorem says the sum of the legs squared is equal to the hypotenuse squared. Well, our lengths for our legs are negative 3 and 5. So if we use our Pythagorean theorem, we can see that the sum of the two legs squared, 34, is equal to the hypotenuse squared. To undo something that's squared, you can take the square root. Now, you want to ask yourself, does 34 have any perfect square factors? If so, we want to break down and simplify our radical accordingly. We know the square root of h squared is the absolute value of h. There are no perfect square factors to 34, so we're going to have to leave it as is. Again, the absolute value measures the distance from 0, right and left. So if we set that up, we can see the distances that we can go would be to the left a negative square root of 34 and a positive square root of 34. But again, this is talking about the length of our triangle, so we cannot use our negative length because if you think of the direction, we have to use our positive. So here's our hypotenuse value. Knowing our hypotenuse value, we can write our cosine expression. The cosine is the adjacent over the hypotenuse. So our adjacent was 3 to the left, and here's our hypotenuse. Now we want the exact answer, and this is a start. It's not our final answer because we're not allowed to have a square root in the denominator. We have to make sense of it, so we are going to rationalize our denominator by multiplying the numerator and denominator by the square root of 34. Again, when you're multiplying your fractions, you multiply across. So we have a negative 3 times the square root of 34, and the square root of 34 times the square root of 34, that's like squaring the square root, undoes itself, so we just have 34. Double check and see if you can simplify the ratio. And we can't. So here's our exact value for the cosine of theta. If you were asked to find what theta's angle measurement was, you could do that by taking the inverse cosine of your ratio here. Or you could also go back to your picture and you know the opposite and the adjacent, so you could use the inverse tangent to find that angle measurement, like you've done previously.